to give her talk on field methods used to study bats. Thank you.
All right, so I've been studying bats. I live in Tucson. I've been studying bats over 30 years, but I also started caving in 1970. So as cavers, we often see bats in caves. And when we set up camp after a great cave trip, we see bats flying overhead. But if we want to study bats, actually understand them, that's a whole different effort. And no, now it won't advance. There we go. So what we need to do is use a whole toolbox of methods to study the bats. Sometimes we have to capture them so that we can do the specific species, sex, age class. Sometimes we have to do scientific work on them. We can also sample bats with just acoustic sampling with a microphone that's sensitive to ultrasonic sound of the bats. We can do that either passively or actively. Sometimes we want to monitor the microclimate, the temperature and relative humidity in their day roost. We might do that in maternity roosts, bachelor colonies, or where they're hibernating. Bob Beecher developed and built infrared bat counters, which we've been using since 1996. We also conduct emergence counts using infrared cameras and infrared lights. We get information from using radio telemetry projects. And some of the latest, we've been started using passive integrated transponders or PIT tags. So if we need to actually have a bat in the hand, in the Southwest, water is really important to bats. So you can set up a mist net over the water and are able to capture bats. You can also put a net along a flyway. This is a triple high net that's been put in the very entrance of Left-Hand Tunnel in Carlsbad Caverns. And we're trying to capture bats in the hand so that we can monitor for Pseudogymnoascus destructans, the fungus that causes white nose syndrome. We always do our work post-hibernation when the majority of the bats have left hibernation and moved on to spring sites. We use nitro gloves. We pluck individual bats off the walls and ceilings. We look at their general health and we swab them for PD, for the DNA of PD, to see if we have captured in the hand individuals that have the spores. While we were working, we were seeing bats way above our reach, and it was driving us nuts. So I developed the Beecher Bat Grabber 5000, which is an extendable pole with a little apple grabber for apple trees. And because the prongs are a little sharp, I've padded it all so that the bats can just end up in the cup. So in 2023, we swabbed 262 bats using just plucking or taking them off the wall with this at 5 different sites. 4 of them were federal sites, and Fort Huachuca is Department of Defense. Another way, like I said, to sample for bats and look for species, because bat species can have individual call shapes, are to use ultrasonic bat detectors. So what you can use is you get an extendable pole and you put the microphone up above the sound of insects, and you have your main detector here, and it's cabled to that, and that's Wildlife Acoustics. Over here is an echo meter microphone on an iPad. And here is an Apple Anabat bat detector. I've been using these since 2003. The 2 of these are full spectrum detectors, so you get the entire call. The Anabats are zero crossing. So out there now, there are multiple detectors, but multiple amounts of money to get them. You can do it passively or actively. So if you're going to do passive monitoring, you put out a microphone on the landscape and you can go home and it turns on before sunset, turns off right after sunrise. and you point it so that you get the best amount of a bat call. So you don't want the bats to pass just in front of it. You want to look down a flyway so that you get a nice sequence of identifiable species calls. If you do active acoustic sampling, you take your bat detector and you go out at night, and as soon as you hear that you've got a call nearby, you actually follow the bat by moving the microphone, and you get a nice series of identifiable calls. These are really useful in doing species presence. You can develop a species list for some places. You can assess activity patterns across different habitats, across different watersheds. It's very, very powerful, but you cannot assess population sizes because a microphone sitting out on the landscape, a little bat can do figure eights in front of it 10 times and you get 10 files, or 10 bats can pass past your microphone and you'll get 10 files. So it doesn't help you population sizes, but it is tremendous for activity. So here are some sample ultrasonic bat calls. We require 5 to 10 good search phase calls before you can be comfortable in identifying it to species. So here is a nice sequence of good identifiable species calls. This is a feeding buzz. It's garbage, and you can't use this to identify to species. But here you have a really nice sequence where you can go ahead and say, yes, I know what that species is. When white nose syndrome first arrived in the United States, and I would go to professional meetings, when people heard that I was from Arizona, they'd say, oh, you guys don't have to worry about white nose. Your caves are too dry and too warm. But since I'd been caving for so many years, I knew that our bats hibernated in very cold and very humid sites. So we had concerns about specifically two BLM caves in New Mexico. And I started deploying iButton hygrochrons and Hobo Pros. And so these would measure, you program them, they wake up, they take a measurement, and they go back to sleep. So you don't have to ever go in during the winter to disturb the bats. So when we look at the results of these two caves, BLM Cave 55, it's this black area that the bats are hibernating in from 8 to about 9 degrees. If you overlay the appropriate conditions for P. destructans, these bats are hibernating absolutely in the center of, they're totally at risk for P. destructans. BLM Cave 55, we are able to show that, yes, if you measure their microclimate, again, these bats are at risk for P. destructans. So this is very important. You can monitor temperatures and humidity in maternity colonies, but this has been really important for agencies and researchers to understand what species might be at risk to PD. So my late husband designed and built infrared bat counters. So there's a unit on the ceiling and a unit on the floor, and there's an infrared beam that goes between them. And when a bat flies in and breaks that beam, it's recorded as an event and it assigns a date and timestamp. So this runs all night, every night, and you can get the numbers of bats that are in a colony. So then when you graph it, you can see that this is a cave that has two species, cave myotis and the lesser long-nosed bats, or leptos, the nectar bats. And you can see that the cave myotis emerge first in this nice pulse, and then there's a little gap, and then the leptos start to emerge. Now in August, mid-August, there are so many flowering agaves near this cave, which these bats are feeding on the nectar and pollen, that they don't have to commute long distance, so they can stay in the area and fart around. And it's like giving a 2-year-old a Snickers bar. They're just totally on sugar. So they're farting around, and then right before sunrise, they come back in and the cave myotis come back in. So this is a night long on on the 22nd of August, the activity in and out of this cave using the infrared bat counter. Another thing we use that's really, really helpful is those infrared emergence counts. We use an infrared camera and infrared lights. Bats are very disturbed by white lights, but they seem to have more natural behavior with infrared lights. And you never stand in the flight path because they're going to be circling in the entrance room. They're going to be scared. What you want to do is have them emerge sort of perpendicular from the cave out past you. And so these bats are going past this rock wall, and you are totally out of the way of that flight. So hopefully this will work. Okay, this is a video in real time. I am not speeding this up, of how these bats are leaving this site. And I'm standing there with an inventory counter going 10, 10, 10, 10, 10, and I'm getting carpal tunnel. When I go home, I can slow that same video down and then get a much better handle on how many bats are emerging and in the cave on that particular date. So when I do a manual count those nights, and we have the infrared bat counter. So we're checking to see how accurate this bat counter is. So I get a count, and I look at what the bat counter says, and I plot them. And then I can do a linear regression, and I can see how close the infrared bat counter is to the actual. And this is a fairly reasonable relationship. So all those nights that I wasn't there, if I wanted to know how many bats were in and out of the cave, I can estimate it after that correction. Radio telemetry is also really, really powerful. You can look at how the bats are foraging on the landscape. And so these are the leptos, and they're feeding on these paniculate agaves. They're flying up and sticking their tongues in to get nectar and pollen. But you can also capture them where they're foraging and track them back to an unknown day roost. So that's what we did. We went to where there were hummingbird feeders that were being drained, but we had no idea where a roost was. So you catch the bats in the nets, and you put on a radio transmitter. It has a little battery. It has a crystal that powers a crystal that's a particular frequency. So it's going beep, beep, beep. And then you go out, send multiple teams out with Yagi antennas and radios, and everybody's listening. They're scanning through the frequencies of the bats that you have on the landscape. And everybody knows where the other teams are. So in the dark, you suddenly get, oh, I got it. And so you get on the radio and you say, this is station 3, and I got bat 65 to my northeast. And because everybody knows where everybody is, everybody swings their antennas to get some triangulation. So every station gets a true bearing once they've gotten a good, strong signal. So if one person has a station, it could be anywhere from 2 to 5 to 10 miles out that bearing. But as soon as someone from the side gets a bearing, that helps control where that bat is. And if you get 3 stations, that is a triangulation that really helps you know where those bats are. So this is a study where we looked at how they were foraging, but we really wanted to know where the roost was, because there were no known roosts in over by Arivaca. So if you draw a 25-mile radius around the capture site, it's about 2,300 square miles that roost could be in. So it's really, really needle in a haystack. So you start seeing where the bats disappear. You go up, move a little bit, move your stations, and finally we found an unknown post-maternity roost with 8,000 to 10,000 leptos. And we were right at the edge of where those bats were foraging. We were just very serendipitous we knew where those bats were coming from because we tracked them with radio telemetry back to that roost. Something that's less labor intensive, but we've had significant results, are using passive integrated transponders, PIT tags. So your vet can put one of those in your cat or your dog, and dog shows up at the pound, they scan the dog, they say, call Fred, his dog got out again. But how we use it is we capture bats away from the roost so we're not disturbing the colony. And we have to have an antenna at the cave that they're using. So these antenna systems are fairly expensive. And we've started using this at Kartchner. So the cave is here. We're capturing bats out here at the tank. And every bat using Kartchner has to go through this hole. And so here's the antenna. There's no battery on the PIT tag, but when there's electricity running through the antenna, and when the bat flies through, it emits that unique number and puts it into a date and time stamp. So some of our significant results were in 2009, we tagged a adult female, and she'd been coming up into 2021. She was an adult when we tagged her, so her minimum age is 12. In 2012, we tagged a male adult, and he was still coming back 11 years, but he could be 12. Remember, he was an adult. In 2013, we tagged a bat that was coming back still this summer, and an adult male in 2014 that was still coming back this summer. So we're looking at longevity and loyalty to the roost. Females are very loyal to maternity colonies. Males will check in and then maybe disappear and go to a bachelor colony. So a new project that colleagues and I are working on, and Sandy and Dave were working on this, and I saw that they're on the one of the participants. This has been a really significant study on, again, leptos. So colleagues in Mexico studying leptos, Sandy and Dave and some other colleagues in the US have been putting PIT tags in these bats. I'm monitoring a cave on Fort Huachuca, and this is the antenna around the entrance. So when a bat flies in, or a PIT tagged bat flies in or out, the tag emits its number, and the date and time stamp is recorded. So some of the more significant results are, there was a female lepto at a maternity colony on Isla Carmen in Baja that was tagged in 2015. We detected her on Fort Huachuca the entire month of August in 2020 and 2021. Now, this is just a tentative crossing. This is assuming she's island hopping, but we have no idea how she was coming across. We know she spent the month of August on Fort Huachuca. There's a maternity colony near Hermosillo, and I've been detecting those tags. There's a maternity colony in the Pinacates, and we've detected those bats on Fort Huachuca. So these are maternity colonies in Mexico. And once the young can fly, these bats migrate to the Gavi fields in southeastern Arizona and southwestern New Mexico. So there's a maternity colony on Organ Pipe, and I've detected animals that have come from there, and a post-maternity colony in the boot heel of New Mexico. I've twice detected those bats back here at the fort after they were tagged. What was really an interesting, to show how amazing these bats are, one of the bats was tagged in the Pinacates, and David and Sandy had an antenna at Organ Pipe, and this female showed up later at Organ Pipe, and then the female showed up at Fort Huachuca, and then she went back to Organ Pipe. So they can just do amazing things in this whole area of moving about. And this year, there's been a lot more PIT tagging in southern Arizona and New Mexico, in the hopes now that we'll detect some of those animals in a lot of maternity colonies down here in Mexico. But again, these antennas are really expensive, so they're more roosts than we can afford to put antennas. So this year, 2023, we detected 41 pit tagged leptos on Fort Huachuca. So this work has been going on since my using these techniques has been going on since 1996. So there's many more people to thank than I can possibly get on this slide. But if there are questions, I'm going a little over, but I started a little late. So if there are any questions?